Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to continue to discuss inheritance and polymorphism. In a previous lecture, we began discussing the concept of inheritance. Inheritance allows data and methods to be inherited or absorbed from one class into another. In Java, this occurs between two classes, the subclass, the child, and that's the class that's inheriting from the other one, and the superclass, the parent, the class that is being inherited from. This is great for extending the properties and functionality of one class into another. The subclass becomes a more specific version of the superclass, and the superclass is a more general version of the subclass. This also creates what's called an is-a relationship that is denoted by a block arrow. We then started discussing this other concept that's called polymorphism. One becomes many. A superclass can be extended or implemented in many different ways. A change to the superclass can be reflected across all of the subclasses. This allows substitution of one class for another as long as the class is an extension. In the previous lecture's example, this is how the dot equals method worked for all of the different types. And this is all made possible by a concept called dynamic binding, otherwise known as late binding. Today we're going to further explore this idea of polymorphism. Now another way to think about that is polymorphism is many forms. Actions or functionality, in other words methods, can be implemented in many different ways. As we saw before, the dot equals method and the toString method were implemented differently for each one of the different types. This also allows changes in the subclass's methods to be applied to the inherited superclasses. Looking at a part from the previous example, we created an array of type person. As we know, person can be considered the base class. Student extended a person, so student is a person, and undergraduate is a student which is a person, so that could be substituted as well. So when we first constructed this new array of type person, we then constructed the first element as the type person. Then we constructed the next element of type student, which is a person, and we can do this only because student extended a person. Then the third element, we constructed an undergraduate, which is a student, which is a person. We can use undergraduate in the same way because effectively it is a person. We then created a for loop that's going to system.out.println each one of the elements inside that array of people. And as we know, whenever we call system.out.println on an object, it calls the toString method. So let's see how this actually worked. Index 0, that was an instance of a person. So then it's going to jump to the toString method inside a person, which is going to concatenate together name plus the person's name. When we get back here, that prints out name ASDF. Now we increase the index by 1, and now we're on people at index 1, which is a student. Now this is what it means by we allow the changes in a subclass's method to be applied to the inherited superclass. Because we overrode the toString method, we call student's toString method, which is going to append a call to super.toString with ID and the ID. As we called super.toString, the superclass is person. So this calls the person's toString method that creates the string name, appends the name, returns that, which appends the ID with the ID, and then when we return to here, it prints out name ASDF2 and the ID of 4. Now we increase the index by 1. Now we're at people at index 2, which is an undergraduate. And to see this concept again, we then call the undergraduate's overridden toString method, which is this. We call super.toString, and then we append together level with the level. Super.toString, for an undergraduate, the superclass was the student. Now this one calls super.toString, which is a call to the person. This returns name with the name appended. Then that appends together ID with the ID appended. And then that returns together all of that and appends together level with the level and then returns this, so it prints out name ASDF3, ID5, and level 2. As we can see by this example, the toString method can be implemented in several different ways, and this was dependent on the type. The person had a specific toString method that related to its property name. Student had a toString method that combined together the name with the ID. Undergraduate had a toString method that combined together the name, the ID, and the level. The toString method could take many forms. Now, in relation to polymorphism, there is a very important structure called an interface. Now, an interface is very similar to a class. Much like a class, this creates a type that we can use. And also, similar to a class, the identifier of an interface must match the file name. Now from there, interfaces differ from classes. First of all, in the concept, an interface defines the functionality, in other words the methods, a class must implement. Interfaces create a non-constructible type. You can only construct classes that implement an interface. And classes that implement an interface can be assigned to the variables of that interface type. Along with that, interfaces only contain method signatures. There is no method body or any kind of functionality. In addition to that, interfaces do not contain instance variables. One of the best ways to think about an interface is it creates a blueprint to create classes. And classes are blueprints to create objects. Interfaces define what a class must do. In order to create our own interface, what we do is very similar to a class. Inside a file, you have public, but instead of class, it's interface, then the ID of the interface. Then inside the body of the interface, you have only the method signatures. And as you can see, we have an example right here. And notice, for each one of these methods, there is no method body or any type of functional code. We use the reserved word implements between a class and an interface. So in order to do this, we would have a public class, the class ID, and then we would say that class implements this interface. Our example here is we have a public class, this one's called basic shape, and this implements this interface called shape. It is important to note, if a method is not defined in a class that implements an interface, then the class will have a syntax error. Remember, interfaces only contain the method signatures. Every one of those methods must be implemented inside of the class in order for this to work. Interfaces are very useful for when functionality of a class can be done in a variety of ways. Now, in order to use an interface, what we have is simply this. Just like a class, you have the interface ID, that's the type, followed by some sort of identifier. Then what you can do is assign the identifier to a new class constructor. Once again, interfaces create a non-constructible type. You cannot construct an instance of an interface. You can only construct an instance of a class that implements that interface. So in our example, our interface was shape. And what we do is we construct a basic shape because this implemented this interface shape. However, this would create a syntax error because you cannot construct an instance of an interface, only a class that implements that interface. Now, let's see an example of how this works. Here's our problem. We need to create a shape drawing program. Now, this program needs to be able to draw a variety of shapes in the console. Now, as we are gathering the requirements for this program, it was also mentioned that each one of the shapes needs some sort of horizontal and vertical spacing. So in other words, if we wanted to draw a shape a few spaces over or a few spaces down, this should be built into this program. Now, some of the shapes that were mentioned as we were gathering requirements for this was a rectangle and a triangle, but there might be more types of shapes. It was also mentioned that some of these shapes could be drawn in a variety of ways. So we could have a filled rectangle or a filled triangle, or a hollowed rectangle or a hollow triangle, or maybe an upside down triangle, a checkered rectangle, a horizontal striped rectangle, vertical striped rectangle, etc. As we were gathering these requirements, we noticed that this software might be extended in a lot of ways. So now we need to carefully design this software in order to extend it in the future. So first, here's what we're going to do. We're going to define this interface. And once again, we're going to use a UML class diagram. Notice, this is shape and the interface is denoted right here. Now, whenever we were doing class diagrams, it had three parts. The first part was the identifier, the next part was the variables or the data, and the last part were the methods. As we must remember, interfaces do not have instance variables. They don't contain data, only the signature of the methods. So, what must all of these shapes be able to do? Well, as we mentioned before, we need to be able to draw this shape maybe a couple of spaces over horizontally and maybe a few spaces down vertically. So we recognize there might be a property that corresponds to the horizontal spacing. So we need to be able to get and set that horizontal space for each one of these shapes. Also, we need to be able to draw each one of the shapes. If this is a shape, it needs to be able to be drawn to the console. And also, maybe we need to create the functionality where we can skip down a number of lines and draw this shape at some sort of line number. So this interface defines that every single shape that implements this must have every one of these methods. However, you cannot create an instance of this shape. You can't construct instances of interfaces, only classes that implement the interface. So this means we need to create a class. Let's call this a basic shape. And as you can see here, this is a class. This is the class's identifier, and this is the property horizontal space that will skip some number of spaces and then draw the shape after it skipped that. Now, notice this. We have the methods set horizontal space and get horizontal space. Well, those are right here. But also, we have the methods draw shape and draw shape at, which are right there as well. There's also a static method that we'll discuss in a little bit, which is skipping horizontal spaces. Now that we have this interface and now we have this class, what we must do is connect them. We denote this by a dashed line and a stick arrow. And the way that you can read this is the basic shape implements this other shape. So now with all of that being said, let's go ahead and start this project. As you can see, we have the project ready to go. So the first thing we're going to do is create an interface. So we're going to right click and we're going to create a new, and this time not a class, but an interface. And this interface's name is going to be shape. Now what we're going to do is write the method signatures for everything that every shape is going to be able to do. Public void set h space. The horizontal space, and we'll just create a parameter called AH. Now once again, we write the method signature, but not the method body or any functionality. Next, public int get h space. So return the amount of horizontal space that we have. Next, public void draw shape. If this is a shape, we need to be able to draw it in the console. And also, public void draw shape at int line number. Now the h space corresponds to the horizontal spaces that it's going to skip before it draws the shape. This one will indicate the number of line numbers that it will skip down before it will draw the shape. Now also, as we're doing this, I'm going to go ahead and create a tester in order to demonstrate what is happening here. So I'm going to create a new class, and I'm simply going to call it tester. And I'm going to include the main method. And also, just like always, include my name at the top of the class. Now the next thing I'm going to do is I'm going to create an instance of that shape. Interfaces, much like classes, create a type. Whenever we are declaring a variable, we start with the type, followed by an identifier. So now, this is going to be an instance of this shape. But there's something very critical to note. Watch what's going to happen. if I assign this to new shape, this is going to give me a syntax error. Interfaces create a non-constructible type. We can only construct a class that implements this interface. So this would cause an error, and I'm just going to comment it out. The next thing that we're about to do is create a class that's going to implement this type shape. So let's go ahead and do that. I'm going to go ahead and create a new class, and I'm going to call this one Basic Shape, and put my name at the top. Now basically what I want to do is say this basic shape is a shape. In other words, for an interface, this implements the type shape. Now this basic shape is a shape. But notice, we have a syntax error right here, and that's because we have not defined the methods set hspace, get hspace, draw shape, and draw shape at. Until we do this, until we've implemented every one of these methods, we're going to have a syntax error on the type. So let's go ahead and start filling this in. We do have an instance variable, and it's going to be called private int hspace, the horizontal spacing. Next, we're going to do our constructors. Public basic shape. And we're going to set this.hspace is equal to 0 initially. And then we create the parameterized constructor. This doesn't change. Basic shape. We'll say int a horizontal space. We'll come back and fill in the mutators in a minute. Now let's go ahead and create the accessor. Public int get hspace. Return this.hspace. Well, this is excellent because this is one of the methods that we needed to implement inside of here. Now we need to write the mutator, which is actually right here as well. So let's go ahead and do that. Public void set hspace int ah. Now we need to error check. If the parameter ah is greater than or equal to 0, then we can safely set this.hspace is equal to ah, but otherwise set it to something valid, like the default value of 0. Then inside the parameterized constructor, this.set hspace to ah. Well, this is fantastic. We've taken care of 2 out of the 4 methods that we need to implement inside of here. The next method that we're going to focus on is public void draw shape. The whole purpose of this program is to be able to draw these shapes inside the console. So now I need to think, what is a basic shape? Well, let's say that it's just a simple point. So I'm going to call system.out.println, and we're going to print an asterisk. Oh, but wait a second. We have this variable here that corresponds to the horizontal number of spaces. If this horizontal spacing was not 0, then we need to skip a number of spaces horizontally before we even draw this. Now, this type of functionality feels like it should be a part of every single shape. However, it doesn't feel like that it's going to pertain to any particular instance. Now, this is why we're going to create a public static void skip spaces int ah. This functionality might be used for other types of shapes as well, so we don't want to make this a part of every instance of this. We want to save some space in memory by defining this statically to be used by every type of shape. Now, what we're going to do is for int I is equal to 0, I is less than the parameter ahi++. And simple enough, we're going to call system.out.print, and we're just going to print a space. Now notice we didn't use print line because we're skipping horizontal spaces. Now we can use this. Inside of draw shape, I'm going to call the static method skip spaces with this dot hspace. So now, whenever we call this, it's going to skip a number of spaces horizontally that's based on this instance variable, but using this static method, And then it's just going to draw an asterisk, a point. Now we're almost done. The last method that we must implement is public void draw shape at int line number. Now in this case, what's going to happen is it's going to skip a number of lines vertically before it draws the shape. So simple enough. For int I is equal to 0, I is less than the line number parameter I++. Inside the body of the for loop, system.out.println, that way it skips a number of lines. And then it needs to draw the shape. Well, easy enough. Let's just call draw shape. So then in this method, it's going to skip a number of lines vertically. Then it's going to call draw shape, which is going to skip the number of spaces horizontally, and then draw the asterisks. Now that we've implemented every one of the methods that were defined inside of the shape interface, the next thing that we can do is start using this. Going back to our tester. Now watch this. We can create shape S. Once again, this is the interface shape, and we created an identifier called S. Now what we can do is construct a new instance of the basic shape. Notice there's no error here because this is a class that implements, that is a shape, and we can use it just like this. And then we can call s.drawShape, and then running this, well, it just draws a point. Now that's fine, we're able to draw one shape, but what if we had an entire collection of these shapes? So in other words, let's say that we had an array of shapes. And notice, this is the interface, but this is a type. So I'm going to create an array of shapes. I'm going to name it shapes, and I'm going to construct a new shape of, let's say, size 11. Now this is creating an array of this type, but this is not creating an instance of that type, only the array. So this is just creating 11 shapes. Now I'm going to define each one of the shapes one at a time. Let's just see this. Shapes at index 0. Now we need to construct an instance, and the only one we have so far is this basic shape, and let's just construct one of them. Let's go ahead and construct another instance of a shape. Shapes at index 1. Let's construct it this way. A new basic shape, and let's say its horizontal space was 4. Now I'm going to enter down a little ways, and watch this. Now for int I is equal to 0, I is less than shapes.length I++. Inside the body of the for loop, if shapes at index I is not equal to null. And we definitely have null elements in this array. We've only constructed 2 of these. We want to stop if it's null. But from there, watch what's going to happen. Shapes at index I, and then I'm going to call .drawShape. Let's see what happens. Well, this was the first shape that was drawn, and now we have this array of shapes, which then drew another basic shape, and then we set the horizontal spacing to 4, so it skipped 1, 2, 3, 4 spaces, and then drew this dot. Now let's see another variation of this. I'm going to comment this out, and I'm going to say shapes at index I, dot draw, shapes at line number I. So as I keeps increasing, we keep jumping down a number of vertical lines. Running this, here we go. We draw this first shape, we skip a line, and then we draw the next one. Now I'm going to go ahead and comment that out and just call draw shape. We're going to come back and forth to this. But now what we need to do is create more specific versions of this shape. So this is what we currently have. But something that was mentioned in the project description is we need to create a rectangle. Now, it was also mentioned that this rectangle could be drawn in a lot of different ways. But one thing that we can be sure of is a rectangle has a length and a width. So easy enough, I'm going to create another interface called rectangle, where for each one of the rectangles, it needs to have a get width, get height, and set height. Each one of these methods must be implemented for any rectangle because it must have those properties. Now wait a second though. We want to make sure that this rectangle is a shape, so that way it does have a horizontal space, and also it has the functionality draw shape and draw shape at. So what I would like to do is have rectangle inherit from this shape. In fact, this rectangle is going to extend the type shape. Now, as a reminder, the dashed line with the stick arrow is implements. Now let's go ahead and write the rectangle interface and make that inherit from the interface shape. So what I'm going to do next is create another interface, and this one's going to be called rectangle. Now, in order to establish that a rectangle is a shape, we say extends shape. Then we write the method signatures that we need for these rectangles. Public int get width. Public int get length. Public void set width. Public void set length. Inheritance allows us to absorb methods and properties, and the same thing applies here with interfaces. So whenever we define a specific type of rectangle, not only must it have get width, get length, set length, but it also must have set h space, get h space, draw shape, and draw shape at. However, we cannot create an instance of this type. We need to create a class that implements this interface in order to do that. So going back to our design, we need to create a rectangle, and let's just call this a basic rectangle. Now, as you can see here, we have width and we have height, and we have the methods get width, get height, set height, and also draw shape. This basic rectangle is going to implement our rectangle interface. Now, as mentioned before, we need all of these methods implemented inside of here in order for this to not have a syntax error. But also, since rectangle, this interface, is a shape, we need all of these methods also implemented inside of here. But wait a second, I'm noticing something. We've already written set h space, get h space, draw shape, and draw shape at. I feel like none of these methods are going to change from our basic shape. So what I'm going to do is not only is basic rectangle going to implement this rectangle interface, it's going to inherit from the basic shape. So in other words, this basic rectangle implements the interface rectangle, but also extends the basic shape. Thus, it absorbs all of the properties and all of the methods from this basic shape, but also requires that this basic rectangle has all of these methods along with all of these methods implemented inside of it. Now this is where design can get a little bit tricky. Let's see how that looks in code. So now we're going to create a new class, and this is going to be a basic rectangle. Now, as mentioned before, this basic rectangle extends the basic shape, but also implements the interface rectangle. Now in Java, it needs to go in this order. Also, in Java, you can only extend one other class. However, you can implement any number of interfaces. Now from here, we're going to define the instance variables. Private int length, private int width. Then we're going to create our constructors. public basic rectangle. Now, as this basic rectangle is a basic shape, we still need to call basic shapes constructor by using super, because the basic shape is the superclass of this subclass. From there, we're going to set this.length is equal to this.width is equal to 1. Now we need to create the parameterized constructor, public basic rectangle. Now if we remember, as this basic rectangle is a basic shape, the basic shape had one property, and that was the horizontal space. So we need to include that in our parameters. Int AH for the horizontal space. Then int AL for the length and int AW for the width. From there, we're going to call the basic shapes parameterized constructor by calling super with AH to set the horizontal space. Then we're going to wait and then write our mutators in order to set the length and the width if it's correct. Now let's go ahead and do our accessors. Public int get width, return this.width, then public int get length, and return this.length. Then we need to create our mutators. Public void set width, int AW, and let's say if the parameter AW is greater than or equal to 1, then it's valid. So then we can set this.width is equal to AW, but if that's not true, this.width is equal to the default value of 1. Now we just need to do the same thing for set length. Public void set length, int AL, and if AL is greater than or equal to 1, then we can safely set this.length is equal to AL, but otherwise set it to the default value of 1. And there we go. Now we've written the methods getWidth, getLength, setWidth, and setLength. Now the only thing that we have to do is write all of the methods that were built into shape, because currently we have Wait, we don't have a syntax error here. But hold on a second. Rectangle needs to have all of these methods implemented inside of here. But because rectangle is a shape, we need to have all of these methods also written inside of here. So why isn't this causing a syntax error? This is because the basic rectangle extends this basic shape. It has absorbed all of the methods and all the properties from here. And as we can see, draw shape at, draw shape, set hspace, and get hspace were already defined, so we don't need to redefine those inside of here. However, the idea of polymorphism is these actions can take many forms. Inside of the basic shape, we only draw a simple point inside a draw shape. If we're drawing a rectangle, we need to override this draw shape method in order for this action to be different, to take a different form. So now we're going to override public void draw shape. And this is how we're going to do it. For int I is equal to 0, I is less than this.length I++. So before we start drawing the shape, we need to skip those number of horizontal spaces. So we wrote a method to do this, so we're going to call skip spaces. However, the property, the horizontal spaces, is built into the basic shape. So we need to access that by calling super.getHspace. That way, this skips a number of horizontal spaces before it starts drawing this rectangle. Then from there, for int j is equal to 0, j is less than this.width, j++. Side of here, we're going to call system.out.print. That way it stays on the same line, and we're just going to print an asterisk. We're going to assume this basic rectangle is just a filled rectangle. And then outside of here, system.out.print line. Now, after we have all of this written, let's go back to our parameterized constructor and make sure that we call this.setWidth and assign AW, and also this.setLength, assign that to AL. Now that we've fully written this class, let's go to our tester and create some of these rectangles. I'm going to now assign shapes at index 2. And I'm going to construct a new basic rectangle. And let's say the horizontal spacing for this one is 0, and its width is 2, length is 3. And while we're at it, let's just create another one. Shapes at index 3 is equal to a new basic rectangle. Let's say that this does have a horizontal spacing of 2, and it is a 3 by 4. Now let's see what happens. Inside of the array, our first shape is a basic shape. It drew a point here. The next one was a basic shape with a horizontal space of 4. The next one was a basic rectangle that was a 2 by 3 with no horizontal spacing, which drew this. Then the next one was a 3 by 4 with 2 horizontal spaces, and it drew this. But notice, there was no errors by doing this because this basic rectangle is a basic shape, and all of those are shapes. We didn't have to edit any of this code because the thing is, using polymorphism, the one method, draw shape, became many different forms depending on what it is. But there's also something else to this. What I'm going to do is I'm going to comment out that line of code, and I'm going to uncomment this one. Now this was draw shape at, and remember, this is the one where we had the line number that skipped down some number of lines. Running this. We drew the first shape, skipped a line. Then we drew the next shape and skipped 2 lines. Then we drew the next one, then we skipped 3 lines, and then we drew this shape here. But there's something really subtle about this. The method draw shape at, that was written inside of basic shape, but not inside of basic rectangle. However, notice this. Inside of basic shape, draw shape at, we skip down a number of vertical lines and then call the method draw shape. But as this has been overridden by the basic rectangle, it draws that specific version even though it was defined inside of here. Once again, the method draw shape can have many different forms as we define this polymorphically. However, the rectangle was not the only shape that we needed to create. We do have a basic rectangle, but there were some other ones that were mentioned, like for instance, a hollow rectangle and a checkered rectangle. Now both of these is a rectangle. And in fact, the only thing that we need to write inside of this is to override the draw shape to draw a specific version of a rectangle that's hollow, or a specific rectangle that is checkered. Let's see what that looks like. Now, as you can see here, we went ahead and created both of the classes checkered rectangle and hollow rectangle. And we've also written all the code. This hollow rectangle extends the basic rectangle. Then all we have are the constructors. And then what we have here is we have overridden draw shape. Now we've separated out the functionality where we have draw line that's going to draw the top line, and this one's going to be the bottom line, and also a method called draw sides. Now inside of draw sides, notice this. We skip a number of horizontal spaces, and then we draw an asterisk. And then internally, we skip another number of horizontal spaces, which is the width minus 2, because this is part of the width and this is part of the width. And then we just skip down the next line. However, this is all the code that we needed to write in order to make this work. Now the same thing for the checkered rectangle. Because this extends the basic rectangle, which is a shape. All we needed to do was to override the draw shape method. So the way that this one works, in order to make it a checkered pattern, basically we add together the I and j. Whenever we mod this by 2, if it's an even value, then we draw an asterisk, otherwise we draw a space. And you'll see what this looks like in a minute. Now let's go back to our tester. Let's draw some hollow and checkered rectangles, and here we go. Now let's see what all of this looks like. Well, here's our basic rectangles, here's our hollow rectangles, and here are some checkered rectangles. We didn't have to modify any of this code because we relied on polymorphism to allow this draw shape to take many different forms. But wait a second, we're still not done. Because rectangles were not the only shapes that we needed to create. In fact, we needed to create a triangle. Let's just assume this is going to be a right triangle, and the only property is the height. Now, once again, a triangle is a shape. Then we need to be able to create a basic triangle that implements the interface triangle and is a basic shape. But then also, we had an upside down triangle and a hollow triangle that is a basic triangle. Oh, but wait a second, what about our tester with the main method? The tester has a collection of shapes. Remember, the stick arrow in this case is the has a relationship. This says that the tester has 0 to many instances of these shapes, which could be a basic shape, which could be a basic rectangle, hollow rectangle, checkered rectangle, basic triangle, upside down triangle, or hollow triangle. So now, let's implement all of this. Now, going back to our code, as you can see here, we have the interface triangle that extends shape and defines that we must have get height and set height inside of each one of the triangles. Then, we have our basic triangle that extends the basic shape and also implements the triangle. This introduces the height, and then from here, we define get height and set height, and then we override the method draw shape in order to draw this triangle. Then we have the hollow triangle that extends the basic triangle, and then it overrides the draw shape method in order to draw a hollow triangle. And finally, we have an upside down triangle that overrides the draw shape method in order to draw a triangle upside down where the base is on top and then it goes down to the point. Now, going back to our tester, let's add some of the triangles. Let's add a basic triangle, an upside down triangle, and a hollow triangle. Running this, now we have an instance of these triangles and also all of the instances of the rectangles and the basic shapes that we already created. This one shape became many different forms. Not only rectangles and triangles, but different versions of rectangles and triangles. The functionality could take many different forms, and this is the essence of polymorphism. Now to finish this out, we need to keep in mind, classes extend other classes. Interfaces extend other interfaces, but classes implements interfaces. In Java, classes can implement several interfaces, but only extend one other class. The syntax is we extend first, followed by the implements. And if we implement multiple interfaces, they are separated by a comma. Polymorphism allows software to be very extensible. We can add functionality very easily by using polymorphism. So what we saw was creating a shape, and then creating a specific shape called a rectangle and a triangle, and then a specific version of a rectangle like a hollow one or a checkered one, and a specific triangle like a hollow one and an upside down one. But we can also add additional shapes. Maybe we wanted to draw a circle. Maybe we wanted to draw a rhombus or something like that. Polymorphism makes our code very flexible and allows us to do a lot with it. With all that being said, I'll see you next time.